let's look at this concept of work again. We've got a vector field here in orange, and then if I take the vector field away, you can see the line. And what we're going to do is we're going to have an object move from that first point to now this second point within the vector field, and calculate what the vector field's work is that it's doing on the object moving along that in that vector field. Okay, and so what I've done here is I've created the line here between the points. Well, let me show you what the problem is first. So it says find the work done by the force field zxy in moving a particle from 3, 0, 0 to 3, 4, pi, 0. I did another video with it going along a helix, and now we're going to do this line here in purple. So when you do it along the line, this is the math that's involved. And you have your f of xyz is zxy, and then f of r of t, this is the parameterization of the line going from 0 to 1. T goes from 0 to 1. So when t is 0, we're at 3, 0, 0, and when t is 1, we're at 3, 4 pi, 0. So let's see that on the graph itself. Let's take away this. And so it starts out at 3, 0, 0, and then ends up at 3, 4 pi, 0. 3, 4 pi, 0. So that's what we have with this here. And then, so when you do f of r of t, you get this expression here, and when you take the derivative of r, you get this here, 0, 4 pi, 0. That's 4 prime, r prime. And then when you do f of r of t dotted with r prime, you do this dot product, you get 12 pi. All right, so when we do the math, here we do this integral, your work integral, you get 37.699. So let's see what happens with this graph here. So let's overlay the vector field on it, and let's make these vectors a little smaller. I explained how I did this scaling in the previous video. And so now, as the object moves along, let me just zoom in a bit here. As it moves along the path, if you look at the integration here, if you look at this integration as it moves along the path, let me move s down. I had to change s from the previous video, by the way, to 0 to 1 for it to work out. And then so as it moves, you can see that the total work gets greater as we move along the path. And so there you have it. If you want, you can make the vectors go all the way to the end point there, just by changing what they are, these guys here. So I had it going all the way to 10. Apparently it goes further. Yeah, it goes to 4 pi, which is 12. So I think this is a really cool way of seeing how a force field acting on an object moving along a line helps out. And so apparently this force field is not conservative because we got two different answers, 37.699, and for the helix we got I think it was maybe 400 something, and so it's not conservative. And let's see, how do we know that? Yeah, partial of q, the curl of this is non-zero, and so there you have it. Play around with it.